Hello friends, welcome back to our channel Adami Education. Today we are going to do a few questions based on equations of motion. It is from class 9 and it is available in CBSE as well as in ICSE. So let's begin. So as you know that there are three equations of motion. The first equation is V equals to U plus AT, where V is the final velocity, U is the initial velocity, A is the acceleration and T is the time. The next equation is S is equal to ut plus half at square, where S is the displacement of the body. And the last equation is V square equals to U square plus 2as. Okay, so these are the three equations, and using these equations we are going to solve the questions. Now before starting, let us understand a few concepts. When an object is falling from a height, be it a tower, be it a building, whatever, the object is falling under free fall. If the word free fall has been mentioned, or if it has been said the object is falling under the influence of gravity, in that case the initial velocity is always 0, because we are just dropping the object. We are not throwing it with a given velocity, we are just dropping it, so the initial velocity will be 0 in that case. And if we are throwing an object from bottom and we are throwing it upwards, at the highest point, before it actually starts coming down, at the highest point the final velocity is 0. So we are throwing it with an initial velocity, but at the highest point when it reaches, the final velocity is 0. Why does it happen? Because for a split second it will appear as if the object is at rest, as a result of which the velocity is 0 in that case. Also, if you are considering that the object is moving away from the earth, that means towards the upper region, the acceleration due to gravity is taken as negative. We know the acceleration due to gravity is 9.8 meter per second square. So if the object is moving away from the earth, we are going to take the value as minus 9.8 meter per second square. But if the object is coming towards the earth, that means it is moving downwards, the acceleration will be taken as positive. So these are the few things that you have to remember, and now let's begin with the questions. The first question is, a car starts from rest and attains a velocity of 20 meter per second in 5 seconds. So the first thing that you are going to do as soon as you come across a numerical problem is that we are going to write whatever has been given to us. They have said that the car is starting from rest. That means initially it has no velocity of its own. So the initial velocity is 0. And it attains a velocity of 20 meter per second. That means the final velocity is 20 meter per second. The time given here is 5 seconds. So make sure that everything is in the SI unit. Don't start doing the question without seeing whether the units are proper or not. Now the first question is, we need to find out the acceleration of the car. So over here we are going to use the first equation, which is V equals to U plus AT. Let us put the values. V is 20, U is 0, acceleration we need to find out, so I am keeping it as A, and the time is T. So 20 is equal to 5A and A is equal to 20 by 5, that is 4 meter per second square. This is my acceleration. Now the question is the distance traveled in this time. We need to find the distance. So we can use two equations, either the second or the third equation. So let me use the third equation. V square minus U square equals to 2as. If you want, you can also use the second equation in this case. V square is 20 square, U square will be 0, so I am not writing it. 2 into my A is 4 and S we need to find out. So if I solve it, 400 by 8 is equal to the displacement. So 50 meter is the displacement. So always make sure you're writing the equation before starting. Right, okay, this way, that using the first equation of motion, V equals to U plus AT. Using the third equation of motion, V square minus U square equals to 2as. After seeing the question, you need to identify that which equation you can use in order to find out the solution. Now coming to the next question. A stone is thrown vertically upward with a velocity of 15 meter per second. So as you can see, the stone is being thrown upwards. That means the acceleration due to gravity will be taken as negative. So the initial velocity has been given as 15 meter per second. And like I said you, that when an object is thrown upwards, the final velocity at the topmost height, that is V, it will be 0 meter per second. And the acceleration will be negative, minus 9.8 meter per second square. So you need to find out the maximum height the object is reaching. So we can use either the second equation or the third equation, but since we don't have the time given to us, we are going to use the third equation. V square minus u square equals to 2as. V square is 0, minus u square is 15 square, that is 225. I am writing it directly. 2as, so 2 into minus 9.8 into s. Alright, so minus 225 is equal to, we are going to get over here 19.6 s. So the minus and the minus sign gets cancelled out. We are going to get 225 by 19.6. This is s. So you are going to get the value as 11.47 meter. This is the displacement. Also you could have used, instead of using 9.8, you can also use 10. That is also okay, because 9.8 is always approximated as 10 in order to make our calculations easier. Now the next part of the question, you have to find out the time taken to reach the maximum height. So in this case we are going to use the first equation, v equals to u plus at. So your v is 0, u is 15, a is minus 9.8, and over here you have t. So time is equal to 15 divided by 9.8. So let's see what is the answer. The answer is 1.53 seconds. So this is the time required to reach the maximum height. So I guess you are able to understand how to do it. It's very simple. You just need to understand which equation to use and put the values and get the correct answer. Now coming to the next question. A train is moving with a velocity of 36 km per hour. So the first thing that you can see is that the speed is given in km per hour, which is not the SI unit. So our first work is to convert the speed. Okay. It is brought to rest by applying brakes. So we can understand the initial velocity was 36 km per hour. And since it is brought to rest, that means the final velocity is 0. So let's first convert the initial velocity. 36 into 1000 divided by 3600. Alternatively, you can multiply it with 5 by 18. So you are getting 10 meter per second. Alright. Producing a uniform retardation. Retardation means negative acceleration. So you are going to put a negative sign. Whenever an object is brought to rest, that means it has to be applied with a retardation, or you can also call it deceleration. So make sure you are putting a negative sign in that case. Now don't get confused that why did we take minus 9.8 in the previous case. Does minus 9.8 means that the earth is causing some deceleration in the body? Don't consider it that way. Whenever the object is moving away from the earth, since the gravity will always act in the downward direction, if the direction of motion of the object and the direction of application of the gravity is opposite, that means the object is going up first, the gravity is acting downwards. In that case, the acceleration due to gravity is taken as negative. So understand it in that way. Don't consider deceleration or retardation in the case of motion due to gravity. Now the first question is, you need to find out the time required to stop the train. So we are going to use the first equation, v equals to u plus at. V is 10, v is 0, u is 10, your acceleration is minus 0.5, and over here you have t. So time is equal to 10 divided by 0.5. So you are going to get the answer as 20 seconds. This is the time taken. Now if you want to find out the distance traveled before it stops, let us use the equation number 2. S is equal to ut plus half at square, or instead we can just make it simple. Let's use the last equation. V square minus u square equals to 2as. You could have got the answer using the second equation as well, but it would get much more complicated because there are two terms. One contains t, one contains t square, so you need to do a lot more calculation. That's why instead of using the second equation, I use the third in this case. So v square is 0, u square will be 10 square, 2 into a is minus 0.5, and s. 10 square is 100 is equal to, okay, you have a minus sign over here, sorry I skipped it, and minus 1, so minus s. So minus and minus gets cancelled. The displacement is 100 meters. Simple, isn't it? Let's move on to question number 4. A ball rolls down a slope with an acceleration of 2 meter per second. A ball is rolling over a slope and the acceleration given is 2 meter per second square. It covers 20 meters in 4 seconds. The time has been given as 4 seconds and the displacement has been given in 20 meter. You have to find its initial velocity and you have to find out its final velocity. Let's see. So in order to find out the initial velocity, as we can see over here, we have no other velocity given to us. So we cannot use the first and the last equation because in both the equations we have u and v both. So we are going to use the second equation. S is equal to ut plus half at square. So S is given as 20, u we need to find out. So u into 4, that is I am writing it as 4u, plus half into the acceleration is 2, the time square is 4 4s is 16. So 20 is equal to 4u plus 2 and 2 gets cancelled, we are left with 16. 20 minus 16 equals to 4u. 4 is equal to 4u. So u is equal to 1 meter per second. This is the initial velocity. Now we need to find out the final velocity. Let's use the first equation. V equals to u plus at. U is 1, a is 2, time is 4. So 1 plus 8, that is 9 meter per second. So once you understand the equations, you don't have to actually memorize it, because the more questions you practice, easier it will be for you to remember the equations very easily. When I was of your age, I struggled a lot in remembering these equations, but honestly, once you start practicing at least 5 questions every day, you don't have to put much effort. Those equations will very easily go into your head and you will be able to solve any type of question. Moving to question number 5, which is based on a graph, as you can see over here. So we have a velocity time graph. So using a velocity time graph, we can actually find two quantities. The first is the relationship of velocity by time. We know velocity by time is the acceleration. So if you want to find out the acceleration from the velocity time graph, you need to find out the slope of the graph. We will come across such questions in the next lecture. Today I am not going to move into much detail about it, otherwise you will get confused. And using this graph again, you can find out another quantity, that is v into t. Velocity into time will give you what? The displacement. So whenever a graph has been given to you, either the division relationship between the two axes or the multiplication relationship between the two axes can be found out using the graph. So in order to find out the multiplication relationship, we need to find out the area of the graph. That means if it was asked that we have to find out the distance covered by the object in the entire journey, we would have found out the area of this trapezium. Okay, so let's begin. Let's see what the question is and let's solve it. You have to calculate the displacement of the car after 20 seconds. So make sure after 20 seconds does not mean after 20 seconds. No, after 20 seconds means after the completion of 20 seconds from 0. What is the displacement? That means I told you in order to find out the displacement, we need to find out the area of the graph. So you are going to find out the area of this rectangular region, because they have asked about 20 seconds. So in order to find out the area, since it is a rectangle, we know it will be length into breadth. The length is this part. How much is the length? See, 20. The breadth is this part. So 12. 20 into 12, that is 240 meter. Make sure the SI unit will always be held, or else you can just check whatever units are given in the graph. Now moreover over here you can see that the time is an hour. Don't consider it as hour. Let's make it simple. Consider it to be in seconds, and accordingly you can find out the answer. Next, after deceleration, how far does the car go? So as you can see, the deceleration is happening in this region. The slope is moving downwards, that means the velocity is decreasing. So in that region, how much distance the car has traveled? So in this case, we are going to find out the area of this triangle. So let's do it. Half into height into base. So half into the height is 12, the base is 10, this is the base. So 60 meter. Alright. Now the last question is describe the motion of the car from 0 to 30 seconds. So initially when the car is moving from 0 to 20 seconds, so since they have given seconds, that means the hour which they wrote here is not correct. Okay, so accordingly please change it whenever you're doing this question in your copy. It is not in hour, it is in seconds. So from 0 to 20 seconds the car is moving with a uniform velocity. There is no acceleration. As you can see, the velocity is constant. It is 12 meter per second. After 20 seconds the velocity is slowly decreasing. From 12 meter per second it is becoming 0 meter per second. That means the car is uniformly retarding and it is finally coming to rest. Hope you have understood this question as well. Next, this is the last question for today. Let's see. A bullet moving with a speed of, the speed has not been given. Okay, let us take a speed over here. Let us take a speed as 200 meter per second, because as you know bullets are very fast. So 200 meter per second, let us assume this is the speed. A bullet moving with a speed of 200 meter per second, so the initial velocity is 200 meter per second, strikes a tree and penetrates 10 centimeter into it. So what is this? This is the displacement. 10 centimeters, so we have to convert it into meter. 10 by 100. Make sure you're doing these conversions, otherwise the answer will not be correct. 1 by 10 meter. Find the retardation and the time taken to stop the bullet. So since the bullet is stopping, that means the final velocity is 0. So we need to find out the retardation, alright, and also the time taken. So what can we do in this case? Let us first find out the retardation. V square minus u square equals to 2as. V square is 0, u square will be minus 200 whole square. 2 into a is 1 by 10 into, a has not been given to us. S is 1 by 10, alright. So minus 200 into 200, I am writing it in this way so that you don't get confused. This 10 is going to the other side and this 2 is coming, this particular 2 is coming to the denominator. This is equal to the acceleration. On solving it, the answer is 2 lakh meter per second square. This is the acceleration. As you can see, the acceleration is already coming in negative, which means that it is retardation, right? And like I said you, that whenever an object is coming to stop, that means some retardation is applied on it. The next question is, we need to find out the time taken to stop the bullet. So in this case we are going to use the first equation. V equals to u plus at. V is 0, u is 200, a is minus 2 lakh, and we have to find out the time. So the time will be 200 divided by 2 lakh, so 1 by 100. The time is 1 by 100 seconds. So I hope you have understood the questions which we did today, and I will urge you that please practice as many questions as you can. In physics, numericals play a very important role, and the more questions you practice, your concepts will get clearer and clearer. Next day we are going to do more questions. We are going to focus more on graph based questions, and we are going to learn how using a graph you can find different quantities which are related to the division relationship or the multiplication relationship between the axes. Hope you had a great time enjoying this lecture. Let's meet soon in the next week. Bye everybody. Keep studying.